before, we discussed about the power and torque in the induction motors. Okay, because this is the induction motors. Okay, so the input will be electrical power, and the output, of course, this is mechanical power. Okay, so this is the power flow diagram. Yeah, so we need to analyze the power losses of the induction motor. Okay, so if we have P in, so you get how many P out. So that means P out is P in minus delta P total. That means the total power loss. Okay, so for here we have five power losses. Okay, five power loss. The first one is delta B SCL is a stator copper loss. We have delta B core, that means core losses at the stator, right? Okay, so here is stator side. Okay, for stator side, we have two kinds of power losses, delta B SCL and delta B core. Okay, a stator copper loss and core loss. And the other side is rotor side. Okay, so the power uh, flow from stator to rotor, we say is air gap power. Air gap power, because um, the rotor's magnetic field will go across the air gap and come to the rotor. So here we have air gap power. Air gap power. So we have input power, we have air gap power, and if we continue to consider copper loss, rotor copper loss, delta B RCL, okay, you get the B convert. That means if we calculate BAG air gap power is equal to B in minus what? Minus delta B SCL minus delta B core. And then if we would like to get B converted, okay, converted. That means we convert the electrical power to mechanical power, which is B convert. So B convert is BAG is minus what? Minus delta B RCL. You get B converted. Okay, B converted means the power uh, converted from the electrical power to mechanical power. So here we have delta friction, delta B friction and windage. I mean the friction and windage losses. We have delta B straight, you can get the B out. So does it mean B out or mechanical power? E B convert minus what? Minus delta B friction and windage, right? Minus delta B straight. Delta B straight. So up to now, according to the power flow diagram, you can calculate BAG's B convert and B out. Okay, and B out is mechanical power. Okay, so B out is also calculated by load torque times uh, rotor angular speed. Okay, rotor angular speed. And this one is electrical power, so equal to square root of 3 line voltage, line current, cosine theta. Or we can calculate B in a 3 V phase, I phase, cosine theta. Of course, theta is the phase angle between V phase and I phase. Okay. Yeah, so if we observe this equation, you can guess this one is input power or electrical power. And now, if we see these formulas, this one is output power. Okay, and remember that rated power is always output power. And this is the key. The rated power of any machine is always the output power. This is the key point. Otherwise maybe you cannot get the correct summaries of these questions. Okay, yeah. Any questions? Thế bá. Okay, yeah. Mm. So in this slide, they mention about core loss. Actually we have the core loss come from this data, and we have another core loss could come from the rotors, because at the stator we have stator magnetic circuit, at the rotor we have rotor magnetic circuit. Okay, but we only focus on stator core losses because this is very hard. Okay, and we skip the core losses coming from the rotor magnetic circuit. Okay, yeah. So yeah, this is the reasons here. We only have the core losses at the stator side. Okay, or sometimes uh, we have later on I will tell you. Okay, now continue. Um, this is electrical power. This is mechanical power, output power, mechanical power. So if we follow the direction of arrow here, from B in to B out, okay, from electrical power to mechanical power. So this one is motor, right? The power flow of the induction motors. Otherwise, if here is B in, that means B in is mechanical power, and B out is electrical power. Okay, yeah, that means the reversion of the direction, the reverse direction. So you get the power flow of the generator. Okay, so it depends on the questions. The question give you the object of induction motor or induction generators, and you can use the power flow diagram uh, correspondingly. Okay, so yeah, we know core losses is the combination of hysteresis losses and the current at the current losses. Okay, we discussed before. Okay, so yeah, and yeah, we also discuss about core losses come from core losses come from the rotor circuit, because at the rotor we also have the magnetic core, and core losses come from the stator circuit. Okay, but normally the core loss come from the stator circuits is much that is much higher than that of the rotor circuits. Okay, so here we only mention the core losses at the stator side. Okay, and the core losses at the rotor side is normally integrated into the resonant witness. Okay, yeah. So when we mention about resonant witness loss, okay, maybe it also contains the core losses coming from the rotor circuit. Okay. Yeah, example. Now we have example. Okay, example 2. Okay, so we need to summary. We need to get a summary. The questions, how to summarize the questions. Now look, first of all, we need to consider the object. The object A three-phase induction motors, right? And the second one, we need to consider power. Okay, here they give us 50 HP. Okay, so this is rated power, right? And I mentioned before, rated power is always output power. Again, this is the key point. Otherwise, very dangerous because if you misunderstand the questions, okay, you get wrong answers. Okay, so again, the rated powers is always the output power. Okay, so here we have the rated powers E, the output power equal to what? 50 HP. And every HP is how many watt? Okay, every HP, yeah, 746 watt. Okay, so you get how many watt in total? 50 times 746, you get 37,300 watt. That means 37.3 kilowatt. Okay, what else? The frequencies. Okay, this one is FSE, 60 hertz. Okay, voltage. Okay, this is three phase, so the voltage here is always line voltage. Remember that. Okay, so but this three phase, so the voltage here is line voltage, and you get a 480 volt. Okay, so in drawing 60 ampere, so they give us IL. The three phase, so the current is also like current 60 ampere. This is lagging, right? We have 0.85 power factor lagging. That means we have phase angle theta how many? We have cosine to the power of 1 of 0.85. You get 31.8 degree. Okay, or we say ILE 60 ampere with minus 31.8 degree ampere because like it, yeah, we have the stator copper losses are 2 kilowatt, so we have delta B SCL E 2 kilowatt. We have rotor copper loss delta B RCL E 700 watt, mean 0.7 kilowatt. Okay, maybe I need to close and restart because some yeah, lagging. Okay, yeah. Hey, no, yeah. Okay, okay, so yes, yeah. What else? We have friction windage, right? We have delta B friction and windage 600 0.6 kilowatt. And core losses are, we have delta B core E 1.8 kilowatt. Stray losses are negligible. That means delta B strays is zero. Yeah, we find the following quantities: air gap and power. Okay, so air gap and power is B in minus delta B SCL minus delta B core. So we have delta B SCL, we have delta B core, so we need to calculate B in, right? And we know B in is what? Is square root of 3 VL IL cosine theta. Cosine theta. Okay, do we have VLs? Yes. ILs? Yes. Cosine theta. Cosine theta how many? 0.85. Okay, so we can get a B in, you know. So this square root of 3. VL is 480 volts and IL is 60 ampere. Cosine theta is 0.85. You get a 42.4 kilowatt. Thầy bá, any questions? Okay, so now we have B in, so we can calculate BAG means air gap power. This is 42.2 minus 2 kilowatt minus 1.8 and you get 38.6 kilowatt. So now we have BAG is 38.6 kilowatt. Yeah, of course less than B in. Okay, so next one, B convert. B convert. So B convert is what? B convert is BAG minus delta BRCL. Okay, we already know delta BRCL. So this is 38.6, right? Kilowatt minus 0.7 kilowatt, and you get 37.9 kilowatt. Okay, and we also calculate B out. I mean the output power. The output power is the B convert minus friction witness loss minus stray loss. Okay, so you get how many? You get 37.3. Okay, so this is similar to the output power the question gives us, right? 50 HP. Okay, so 50 HP means B out, right? B out. And if we calculate the power flow diagram, B out also equal to 37.3. Okay, so the result is consistent. And then we can calculate efficiency. Efficiency is the ratio of output power to input power. So the output power is 37.3 and the input power is 42.4. Okay, so you get efficiencies of the induction motors is 88% or 0.88. Okay, any questions? No? Okay, next. Now we consider the equivalent circuit of induction motors. So we know this circuit before, right? Actually, this is I2 overcomers, Q2 overcomers, I2 overcomer, right? Yeah. But for this textbook, they only use I2, X2, R2. So please remember in your mind, I2 or I2 overcome the same, you know. X2 or X2 overcomers. R2 mean R2 overcomers. Okay, and Z2 mean Z2 overcomer. Okay. Yeah. So if we would like to calculate I1, you need to know the equivalent impedance of this circuit, you know. So this one is X EQ, equivalent impedance. Okay, so if we know Z EQ or equivalent impedance, you can calculate I1. So I1 is V phase divided by Z EQ. Okay, equivalent impedance. So how can we calculate equivalent impedance? So look, we have this range, right? This range in parallel with this range, and then totally in series with this one, this range. Okay, so that means we have R2 over comma over S plus JX2 over comma, okay, in parallel with what? With RC and in parallel with XM, you know, this one in parallel with this one and in parallel with this range, okay, and totally in series with R1 plus JX1 here, okay, yeah. So how can we calculate this one? So this one is 1 over 1 over RC plus 1 over XM plus 1 over R2 over comma over S plus J is equal to over comma, right? Right. So yeah, this one equal to this one, and 1 over RC is EGC. Okay, J is XM, sorry, J is XM. So 1 over J is XM is minus BM. BM. We say BM is 1 over XM and 1 over J, that means minus, right? Minus J. Minus J. 1 over J mean J over J square, right? And J square is minus 1, you get minus J. So 1 over J is minus J here. Minus J. And plus this one. Okay, so finally we have 1 over GC minus JPM plus this ratio. Okay, plus R1 plus JX1, you can get the ZEQ, equivalent impedance. Okay, yeah, so when we get equivalent impedance, we can get I1 because we know V phase. So V phase over equivalent impedance, you can get I1. Okay, yeah. So we have the formula to calculate delta B SCL, right? Delta B SCL is what? This is stator copper loss. So this is stator resistance and I1. Okay, and we have 3 phase. So if we have 1 phase, we have R1 times I1 square, and 3 phase we times 3, we get 3 I1 square at R1. So delta B core, okay, core losses E, you know, is this current, okay, and this current, okay. So we have core losses is 3 because we have 3 phase, 3 E1 square. This is 1. E1, you know, E1 different from V phase, you know, E1 is the potential voltage between this point A and this point. Okay, E1. E1 equal to what? E2 over comma. Okay, so we have 3 E1 square over GC. This is conductance. GC is conductance. Conductance. So yeah, of course, everybody know how to calculate this one, right? So the air gap power, right? Delta B is E is what? E R times I square, right? And we know I is what? I is V over R totally square. Okay, that means you get V square over R. So R is resistance. So we have V square over G. G is conductance. And 3 phase, so we times 3. So here you get 3 V mean E1 and G mean GC. Okay, and demonstrate to you. Okay, and we have air gap power. Air gap power is B in minus delta B SCL minus delta B core. Okay, yes. Any questions? Okay, so next. So BH, we talk about BH. So for BH means air gap power, right? Yeah, and of course we have BH is B in minus delta B SCL minus delta B core, or BH will be calculated by this one. So how can you get these formulas? Now pH is here, right? pH is here. Yeah. And if we consider the rotor side, okay, we have this resistor, right? So that means pH is this resistance R2 over F times R2 over comma over S times I2 over comma and 3 phase with time 3. Okay, square. Okay, here, right? So the air gap powers is also calculated by 3 R2 over comma over S, right? Times I2 over comma square. Okay, yeah. And we know delta B RCL is 3I2 square R2, or we say 3I2 over comma squares R2 over comma. Okay, so here we can get delta B RCL over S because 3 times R2 over comma times I2 over comma square is delta B RCL. So if we continue to divide by S, you can get air gap power. Okay. And delta B RCL also equal to 3. What does this mean? I2 over comma mean IR divided by A effect, right? This is square, so this one is square. R2 over comma mean R2 mean what? Mean RR times A effect square. So this is A effect square, this is A effect square, so we delete them. So you can get 3 IR square times RR. Okay, so we have two ways to calculate delta B RCL. Okay, so delta B RCL is 3I2 square times R2, or delta B RCL is 3 IR square RR, like this. That means we can calculate delta B RCL before we refer rotor parameter back to the standard. Okay, yeah, here or here, it's up to you. Now we calculate B convert. So B convert is BH is minus delta B RCL, and we know for BH is E delta B RCL over S. And delta B RCL is what? It's 3I2 over summers over to over to so I2 over comma square, right? R2 over comma divided by S. Okay, like this. Okay, and delta B RCL is here. Okay, so if we take 3I2 square R2 outside this common variables, so inside the bracket we have 1 over S minus 1. Okay, so 1 over s minus 1 is 1 minus s over s. Okay, so we have two ways to calculate convert this power, right? Convert this power. The first one, we calculate convert these powers based on B air gap minus delta B RCL. Or we calculate convert these powers by delta B RCL times 1 minus S over S. Remember that this one is delta B, sorry, this one is delta B RCL. Or here, I just said delta B RCL times 1 minus S over S. Okay, so if we know delta B RCL, we know sleep, we can calculate convert this power. Okay, any questions? Yeah. Any questions so far? Any questions? Dũng, any questions? Nghĩa?
No, I don't have any question to you.
Okay, next. So if we know for B convert, right? We know B convert. And now we have B air gap A delta B RCL y, right, over S. And B converts A delta B RCL 1 minus S over S. Look, right? Delta B converts A. B converts A delta B RCL 1 minus S over S. So, okay. So now we find the relationship between B convert and air gap. Okay. So if we have B air gap over B convert. Okay. So if we have B air gap over B convert, you can get what? Delta B RCL over S divided by this one, right? So that means we have a delta B RCL S, right? 1 minus S. Okay, so delta B RCL, delta B RCL S over S. So you can get 1 over 1 minus S. So after that, you can get a B convert E 1 minus S times air gap power here. Okay, yeah. So B converts E now. B converts E B air gap times 1 minus S or equal to delta B RCL 1 minus S over S. Okay, it's up to you. It depends on the information given to us. We can calculate a B convert. And after you have B convert, we minus delta B frictional windage minus delta B stray. This is stray loss. Okay, you can get B out. You can get B out. Any questions? Okay, so now we discuss about how to calculate the induced torque. Yeah, induced torque. So we have the formula, right? B convert is induced torque times omega m Omega m means motor or rotor's angular speed, rotor angular frequencies. Okay, and this one is induced torque. Okay, tau in B convert. Okay, yeah. To remember that induced torque EB convert over omega m. So we know B convert is 1 minus S times air gap power, right? B convert is 1 minus S times air gap power. Okay. And divided by omega m. And we know omega m, we know Nm is 1 minus S and C, right? So omega m is 1 minus S times omega C. Okay, or we have omega sin a omega over 1 minus S. Okay, so here, 1 minus S over omega m, so you can get air gap power over omega sin, right? 1 minus S over omega E 1 over omega sin. So here you get this one. So we have two ways to calculate the induced torque. The first one, we calculate induced torque based on this ratio, B convert over omega m or BAG over omega sin. Remember that if B converts divided by omega m, B is air gap over omega sin. Okay. Yeah. Next. Now we modify the circuit. Okay. So look at this line, this diagram. Okay. So if we would like to calculate, if you would like to calculate delta B SCL, we need to consider what? If we would like to calculate delta B core, we need to consider RC. Okay, so if we would like to calculate delta B RCL, delta B RCL is what? Is 3, right? I2 square R2. We need to know R2. But for the equivalent circuit, we don't have R2. We only have R2 over S, right? So if I modify R2 over S to becomes R2 over S plus R2 minus R2, it's the same, the same. Okay, so continue. So that means I get R2 plus R2 1 plus S over S. Do you repeat me? Okay, I take R2 here. Okay, minus. Yeah, minus. Okay, yeah. So now if we have R2 over S, now it's become R2 plus R2, 1 minus S over S. 1 minus S over S. Okay, so we have these components to be the combination of R2 and R2 times 1 minus S over S. Okay, yeah. So that is the reason here. We have R2 and R2 1 minus S over S. Okay, so now we appear. We have the appearance of R2, so that means you can calculate delta B RCL. Okay, Of course, delta B friction and windage, you need to make the measurement to get the values, and delta B strain, So now we know this component to calculate delta B SCL, this one to calculate delta B core, this one to calculate delta B RCL, and this one from the experiment. Okay, you can get delta B friction and windage and delta B strain. Okay, so how about this one? So if we come back in the formulas, we know B convert. Now look, B convert, right? B convert. So B converts E delta B RCL times 1 minus S over S. And what does this mean, delta B RCL? So delta B RCL is delta B RCL is 3, right? I2 square R2 1 minus S over S. So this one. So this one. Okay, these components. So this component mean here. Okay. Yeah, and we have I2. Yeah. So when we consider R2 1 minus S over S, this one is related to converted power here. Okay, because B converted E 3I2 square R2 1 minus S over S. Okay, so B converts E directly proportional to this term R2 1 minus S over S. Okay, yeah. Any questions? Thầy Bá, any questions? Okay. Next. So we say this one is R convert. Okay. Yeah, we say this one is R convert, like this, R converse is R2 1 minus S over S. Yeah. So that means if we have R2 over S, okay, we can modify become R2 and then R convert, right? And R converse is R2 1 minus S over S. Okay, yeah. Yes, example. Now we have example 3. We need to summarize this example. Now, summary. We need to summarize this question. So, the object, induction motor. How many phase? 3 phase, because they give us the information of Y connection. Y connection does mean VLE, this is square root of 3 V phase. Do you know VL? Here, 460 volt. Okay, so here the power, right? And I is also mentioned to use many times. The rated power is always the output power. Always the output power equal to 25 HB, mean 25 times 746. Okay, so now we have 25 times 746. You get 18,650 watt. Okay, 60 hertz. That means FSAA 60 hertz. Okay, how many poles? 4 poles. So that means pole pair is 2. Pole pairs. Yes. Hence, the following impedance in all both phase referred to the stator circuit. You know, they already refer to the stator circuit for us. Okay, so that means we have R2, X2. You know, yeah, this one means the rotor resistance and the rotor reactance referred to the stator circuit already. Okay, we also have R1, X1, okay, and XM. We don't have RC, that means RC is 0. Oh, okay, yeah. But they give us the total rotational losses. That means delta B total. No, sorry, it is rotational. So rotation losses mean we have delta B friction and windage plus delta B stray. Okay, here is delta B rotate. Okay, is 1.1 kilowatt. We have core losses. Core losses is lumped in with the rotational loss. So here we have delta B core losses. Okay, 1.1. We have the slip. So the slip is 2.2%, mean 0.022 at the rated voltage and the rated frequencies. Okay, so we need to calculate rotor speed. Okay, so question 8, rotor speed is 1 minus F times NC. That means you get 1 minus 0.022 times NC. What does this mean, NC? Synchronous speed. So we have N sin E 60 FSE over B, right? And we know 60 times FSE, how many? FSE is 60 over BE2. So we can get 1,800 RPM. Okay, so here you have 1,800 RPM. You can get rotor speed, how many? 1 minus 0.022 times 1800. You get 1760 RPM. Okay, so this is question 8 here. Okay, and this is rotor speed, so we can calculate rotor angular speed. So WR or omega R is 2 by NR over 60. That means you get 2 by times NR is 1760 over 60. So you get how many? 2 by times 1760 divided by 60. You get 184.3 radian per second. Okay, yeah, here. Or we can calculate omega m is 1 minus f times omega c. That's okay. So we need to calculate omega c. omega CD 2 by n sin over 60 equal to 2 by 1800 over 60. You get how many? You get 1AA.5 radian per second. Okay, so it's up to you. We have many ways to calculate a rotor angular speed. Okay, this is question B. Stator current. So we have the formula, right? So to calculate stator current, we have I1 E V phase over Z equivalent. Yeah, Z equivalent. Maybe I will stop and yeah, open again because we have some lagging. Okay, so look, now we have I2, sorry, we have I1 is V phase over Z equivalent or V1 over Z equivalent. Okay, and we have the formula to calculate the equivalent, right? Is what? Is 1 over RC plus 1 over JXM plus 1 over R2 over S plus JX2. You know, normally when you add 2 over comma, you know, then plus R1 plus JX1. Okay. So we say this one is Z stator here. And we said this one is ZF. Okay, so that means we can get Z stator plus ZF. Okay, ZF. And then we don't have RC, so skip RC. Okay, so we get what here? Yeah. Okay, yeah. So you get 1 over JXM plus 1 over what is this? This one is Z2 over comma, right? This one is Z2. Okay, so finally you can get ZF is here. Okay, ZF and Z stator. So this is R1 plus JX1, and this is R1. This one is JX1. R1 is 0.641 and X1 is 1.106. Okay, so here. Okay, plus ZF, this is ZF. Okay, so you can get the result here, 11.72 plus J7.79. Or you can get the magnitude and phase angle. So the magnitude is 14.07 with the phase angle 33.6 degree. So this one is ZEQ, right? So you can get I1. So V1, this is phase. This is phase. So, but at the beginning, this is line voltage, right? So if we get a good summary, we can easily determine the phase voltage. So phase voltage is line voltage over square root of 3. That means you get 460 over square root of 3. Okay. 460 over square root of 3. We have 265.6 watt. Okay, so now we have phase voltage 266, and normally phase voltage is similar to the x-axis. So the phase angle is 0. Okay, divided by z total. Here, z total or z equivalent equal to z total. Yeah, and you can guess the phase, the magnitude of I1 stated current is 18.88, and the phase angle is minus 33.6. That's all. Any questions? Okay, so this question C. We calculate power factor. Okay, power factor. Very easy, Power factor very easy. Why? Because power factor is the phase angle between V phase and I1. Power factor at the stator. Or we say stator power factors. Okay, so if we look at the equivalent circuit, this is I1. Okay, it's a V phase. Okay, so we can get the stator power factors. Okay, so V phase normally it is the magnitude of the phase angle 0, and I1 is magnitude of I1 with the phase angle phi 1. Okay, so you get theta is phi 1. Okay, yeah. So now we come back. We get the current. We get the current here. This is the phase angles and the magnitude of I1, and this is V phase. V phase we have 0 degree, and I1 we have 33.6. Okay, so that is the reason we have theta. Theta, that's a 33.6. Okay, 33.6. Yeah. So cosine of 33.6 is 0.833. Lucky. Okay, this is C. So if we would like to calculate rotor power factors, how can we do? Rotor power factors. Okay, so come back. Okay, this is rotor I2, and this one is E1. So if we know E1, how many angle? I say phi E, and we know I2 E I2 with phi 2. Okay, so we can get the power factor at the rotor E phi 2 minus phi A. We take absolute values. Okay, and then we calculate cosine theta R. You can get rotor power factor, right? So in summary, to calculate stator power factors, we need to consider the phase angle of I1 and V phase. Okay, so to calculate rotor power factor, we need to consider I1 and E1. Okay, yeah, I1 and E1, E2, sorry, E2 and E1. Okay, E2 and E1. You can get rotor power factor. Okay, is it clear? Okay, yeah, next. So now question D, we calculate converted power and output power. Very easy, So converted power is, converted power is 1 minus S times air gap power. So we need to calculate air gap power. So air gap power is delta B. Sorry. Air gap power is what? E B in minus delta B SCL minus delta B core. Okay, we don't have information about core losses, so skip it. You can get delta B in minus delta B SCL. And B in how many? B in how many? So B in is square root of 3 V line voltage, line current, okay, cosine theta. And line voltage is 460. Line current we calculate before. How many? 18.88. Okay, 18.88. 18.88. And the power factor is 0.83. Okay. Yeah, here. So you can get the input power is 12,530 watt. Okay. Yeah, and we need to know delta B SCL. Okay, so delta B SCL is 3I1 square R1. We know I1 before, right? 18.88. And R1 how many? R1 is 0.641. I1 is 0.641. Okay, so now we can get delta B SCL is 285 watts. So you can get BH 11.845. Okay. So when we know air gap power, we can get converted power. So converted power is 11,585. Okay, so you can get the output power. So the output power is 14.1 HP. Okay, so now look. The rated power. Look, the rated powers. The rated power is 25 HP. Okay, but when we operate this induction motor with the slip 2.2, okay, so we only get the output is 14.4 HP. Okay, yeah, so this one is higher than B's output rated. That's okay, no problem. But if this one is higher than output rated power, okay, it will be dangerous because the induction motor will be damaged. But now you can see that's okay, because we operate the induction motors at the no rated condition. Okay, so now we have the question E. Yes, that's question E. We calculate induced torque and load torque. Induced torque. So induced torque is air gap powers, right, over omega c, right? We have two formula. So induced torque is B convert over omega m, or air gap power over omega c. Okay, so it's up to you. So if we use air gap power, we need to divide it by omega c, or we can calculate B convert. Okay, B convert how many? Look, B convert is 11585 over omega m, the rotor angular speed. Omega m how many? Here, omega m here 184.4. Okay, 184.4. So you have the same result, I guess. So 11,585 585 divided by 184.4, and you get 62.82 Newton meter. So the same, you you can calculate in Dewey torques based on this formula, or based on this one. Okay, this one, the same. Okay, so we can calculate the output power. Sorry, we based on the output power, we can calculate load torque. So load torque is output power over omega m, and output power we calculate before. You get 10,485 over omega m. Omega m is 184.4, and you get the load torque is 56.9. Okay. So we know P out and we know P in. P out is 10,480. 845 or 485 or 485. Sorry. So here should be 10,485. Okay. Over B in how many? Here. Yeah, 12,530. Yeah, so we can get this efficiency either 33.8%. Okay, yeah, so we finish example. Any questions? Teva, any questions? Okay, so if no questions, we try to answer one of the problems here, one of these homework questions here. Okay, so remember we have homework with 4 questions, 1, 2, 3, 4. Okay, so for maybe I will answers. Yeah, just some such question, not all. Okay, so because we only have maybe it's 15 minutes left. Okay, so here, yes, we need to summarize. Why? Right? So we have we have problems. We have problem number 4. Okay, so we need to summarize the questions. Okay. Yeah. We have Wood rotor induction motors. Okay, 3-phase Y connection. Okay, so we have 3-phase Wood rotor induction motor Y connection. So connect this, right? Yeah, connected. So we have VLE 3 square root of 3 V-phase equal how many? Okay, how many? We have 208 for both 60 Hz. Okay, So 208 volts. So you can get V phase. Okay, if I have some mistakes, inform me, please. Okay, so we have 208 over square root of 3. You get 120 volt. Okay, we have FSA 60 hertz, right? FSA 60 hertz, and 4 poles. That means the pole pay 2. Okay, then here 4 poles 60 hertz, blah blah blah, and the rated power, you know, the induction motor is rated at 30 HP. So that means for the rated condition, you know, B rated is output power always. Remember that is what is 15 HP, right? 30, sorry, 30. Yeah, 30 HP. That means 30 times 746. 30 times 746, you get 2238 watt. Okay, please remember, if I have some mistakes, inform me immediately, because I use my laptop, so for maybe sometimes I didn't remember these values of some parameters. Okay, so we have R1, R2, R1 is 0.1 ohm. Okay, so maybe I zoom a little bit here. Okay, I zoom a little bit here. Okay, so we have R1 is 0.1 ohm, and X1 we have 0.21 ohm. Okay, so we have X2 or X2 over comma E 0.07 ohm, and X2 or X2 over comma is 0.21 ohm also. Okay, and we have XM E 10 ohm, XCE 0 ohm. Next, okay, we have delta B mechanical for loss, as mean friction and windage, a 0.5 kilowatt, and delta B stray is 0 watt. Okay, and then we have delta B core is 0.4 kilowatt. Okay. Oh, yeah. So yeah. And question A. Okay, the slip is 0.05. Okay, so yes, and they give us the slip is 0.05, right? 0.05. So find the line current IL. We need to calculate IL. Yeah, we need to calculate IL. IL mean I1. Okay. Yeah, IL is line current. I1 is phase current. But we have Y connection, so IL and I1 is the same. Yeah, the same. This is phase current. This is stator phase current. Okay. Yeah, and this one, of course, line current. Line stator current. Okay. Yeah. So how can we calculate I1? So I1 is V phase over ZEQ. Okay, so we need to calculate ZEQ. So ZEQ is 1 over what? Over 1 over RC plus 1 over JXM plus 1 over R2 over S plus JX2. Okay. Then plus R1 plus JX1. Okay. So this one is Z stator. No, this one is Z. Maybe we say Z. ZF. Okay. And this one is Z stator or Z1. Okay. Yeah. So please help me to calculate ZF. E 1 over. So we don't have IC. So skip it. Skip. So we have 1 over the XM. XM how many? 10. Okay, 10. So minus J 10 because this is divided by J doesn't mean times the minus J. Okay, plus 1. Oh, we need to calculate S. S. So S, S we have already 0.05. Right, 0.05. So R2A 0.07. 0.07 over 0.05. This is S, okay? Plus J X2. X2 how many? 0.21. Okay? 0.21. So how many, please? Magnitude and phase angle. Degree, how many? Oh, please help me to calculate it quickly because we don't have enough time. So otherwise, we need to stop.
It is 1.37.
1.37.
Angle is 16.3 degree.
16.3 degree. Okay. Okay, so and then we calculate Z1. So Z1 is R1. R1 is 0.1. 0.1 plus J 0.21. 0.21. Okay, 0.21. Okay, so we can get ZEQ is this one plus this one. Okay, and you get how many? We get 1.41 A plus J 0.59. Okay, 96 or equal to magnitude and phase angle. We get a 1 boy. Please help me to double check 1.54 and the phase angle is 22.8. Okay, yeah. So now we can get some E1, I1, sorry, is V phase over ZEQ. So V phase A Okay, we already calculate here, right? 120. So we have 120 over 0 for width of 0, but 1.54 with 22.8. Okay, so you get minus 22.8. How about 120 over 1.54? You get 78 ms. Okay, yeah, please help me to double check, is it correct or incorrect? Please help me. Okay, yes. Okay, so now we finish to calculate I1. Oh, but here we know line current, but this is phase current. Okay, so yeah, so we can get a magnitude of IL is I1 times the root of 3. Oh, equal, right? Equal. So you get the same 78 ms. Okay, 78 ms. Yeah, lies in this one. Okay, yeah. So for next one, question B. We have let me check. The stator copper losses. The stator copper losses delta B SCL. Okay, very easy. You know, delta B SCL is 3 I1 square R1. Okay, so R1 is 0.1, right? And times 3 times I1 square, I1 is here, 78 square. Okay, so we have 3 times 78 square times 0.1. So we can get 1825 watt. Okay. Yes. Okay. So question C. They ask us to calculate air gap power. Maybe I calculate power factor first. Any information about power factors? No? Okay, so we calculate power factors. So we have stator power factors. That means the phase angle S, theta SE, V1 and I1, you know, or V phase and I1. Okay? Yeah, and you know I1 is here and V phase is 0. Okay, look. So that means we have theta SE 22.8. Okay, so we can get cosine theta S. How many? Cosine 22.8. Yeah, we can get 0.91921 like it. And now I would like to calculate rotor power factors, theta R. So theta R is what? Is E1 and I2. Okay, so we need to calculate E1 and I2. So for maybe question C, D, E, F, G, as you know, right? Because they are similar to example 3. So I just follow this one and then we will stop. Okay, so E1. E1. Okay, so again, we have the circuit. We have R1, JX1. Okay, now we have JXM. We don't know RC, right? Because RC is 0. Okay, here, this is I1, this is V1. Okay, this is R2 over S. JX2. Okay, correct me if I have something wrong. Okay, I2. and this one is E1, right? E1. E1. So we need to calculate E1. E1 is what? We apply Kirchhoff. We apply Kirchhoff 2 for this one, for this loop. So we have E1 is V1 minus R1 plus JX1 times I1. Okay. Okay. Yes. So V1 minus R1 plus JX1 times I1. Okay. So V1 is a phase voltage. So you get 120 with 0 degree. Okay. Yeah. Minus what? Minus R1. R1 how many? I don't know. Here. R1 is 0.1 plus J 0.21. So the 0.1 plus J 0.21 times I1. You know I1, right? I1 here. 78 with minus 22.8. 78 with minus 22.8 degree. And now please help me. How many? Right? 0.1 plus J 0.21, 78. Yeah. How many, please? You need to take the bracket here. Times. How many? You get 107.4 with the phase angle minus 6.47. That's correct? I don't know. You need to help me to double check. Okay. So then we need to calculate I2. You know I2. I2. So okay. So for we apply the current dividers. For current dividers, this is I1 and this one is IM, right? And this is I2. Yeah, so if we apply current dividers, we have I2. I2 is JXM. Okay, this one divided by JXM plus R2 over S plus JX2. Okay, times I1. Okay, time I1. Yeah. So now we have JX1. That means J10 over J10 R2 over S. R2 over S mean 0.07 over 0.005. 0.07 over 0.05 plus JX2. I don't know. X2 how many? 0.21. Yes. Okay. Times I1 is 78 with minus 22.8. How many, please? We get 75.69 with minus 11.99. That's mean nearly 76 with minus 15 degree ms. Okay. So now we have theta r is the phase angle between E1 and I2. Okay, we know E1 is the phase angle of E1 is minus 6.47. Okay, and the phase angle of I2 is minus 15. Okay, yeah. So we can get theta r is is minus 50 is minus of minus. That means 6.47. Okay, yeah, absolute, right? You get how many? 15 minus 6.47. You get 8.53 degree. Okay, so now we get the rotor power factors. Cosine theta r is cosine 8.53. And then, yeah, we can get 0.988. Lucky. Okay, lucky because this is minus, you know. Minus, this is lucky. This is minus lucky. So finish. Yeah, and so we finish how to calculate rotor power factors. Okay, and you get 0.988, and we also get some stator power factors. This is 0.91. Okay, please. So we have the others questions, of course, for your homework. So we finish the class in the morning. Any questions? Okay, so I will send you